Let's review unit cells. There are three basic types of unit cell. The primitive or simple cubic, which has one atom contained within the unit cell. The body-centered cubic, which has two atoms contained within the unit cell. And the face-centered cubic, which has four atoms within each unit cell. So let's try a problem. Gold exhibits a face-centered cubic unit cell that is 4.08 angstroms on a side. Estimate gold's density in grams per cubic centimeter. So there's the equation for density. Clearly we're going to need that if we're going to calculate density. Gold has a face-centered unit cell. What we can see here is we can see the atoms in the corners, which I've colored black, the atoms top and bottom, which I've colored blue, left and right, which I've colored red, and front and back, which I've colored green. And we can fade that into a more accurate representation, possibly, of the gold face-centered cubic unit cell. So watch that unit cell and watch how it fades into gold, like that. Density is an intensive property, so whatever the density of this unit cell is, that is the density for any larger sample of gold. So let's try and figure out the density of this unit cell. What about the numerator, the mass? The mass that is in this unit cell, well, we know that there are 4 atoms of gold in that unit cell. And from the periodic table, we know that the typical gold atom has a mass of 197 AMUs. We actually do know the mass inside that unit cell. It's 4 times 197 AMUs. What about the volume? We're told in the problem that the unit cell is 4.08 angstroms on a side. Well, the volume of any cube is the side length cubed. So this is where we stand at this point. There's the mass that's within this unit cell, and there's the volume. Now, of course, those units aren't right, because we're asked specifically in the problem to use grams per cubic centimeter. We just need to convert this into grams per cubic centimeter. Let's convert into cubic centimeters first. We're supposed to know that an angstrom is 1 times 10 to the negative 10th meters, or 1 times 10 to the negative 8th centimeters. If we put times 10 to the negative 8th right there, where that angstroms is, we can take 4.08 times 10 to the negative 8th, and we can cube that number, and that's the denominator. Multiply 4 into that equation, multiply 197 in there, and we get a number that looks like that. Now, what are the units on that number? We can see from the work we've shown near the middle of the slide here that the atoms have canceled, AMUs has not, and cubic centimeters has not. So that is AMUs per cubic centimeter. All we do is convert that into grams per cubic centimeter. The cubic centimeters we don't have to touch, and we're supposed to know that 1 gram takes Avogadro's number worth of AMUs. Cancel the AMUs, and there you have grams per cubic centimeter.